here, Kaufman, slides, right? Because I talked about inheritance, but I didn't really talk about interfaces too much, right? I mentioned them in class, right, about how they're really basic really basic ways to get inheritance without having any kind of thing that we have to do with them. So let's talk about like what kind of polymorphism problems you might see on an exam, okay? Typically, you'll see like a bunch of classes that are put together. You have some client class that calls a bunch of objects, and then you have to read the code and figure out what is the output. Okay, they're almost always such on the final exam, something like this, where we've got a class called foo, right? And it's got method 1, method 2, and toString, and typically they're not more complex than that. It's just a class, and they've got method 1, which prints out like foo1, method 2, which prints out foo2, and a toString, which like prints out the class. Okay, that makes sense, right? Foo isn't too intense there. And then you might have a class like bar that extends foo, right? So far, so good there, right? It's a class that extends foo, and it overrides method 2, right? So if we create a new bar class, right? If we create a new bar, we go like, let me go ahead and just pull up a scratch pad here. Say I created a new bar B, so like bar B is equal to new bar, right? Okay, say I create that. If I do B dot method 2, right? My output should be, let's go ahead and just copy them over so that we can see them here, right? Because on the exam, you're not really going to get too much syntax highlighting, right? So if I call B dot, B dot method 2, what should my expected output be? Right? It says over here I should get bar 2, right? Not a trick question here. If I call B dot method 1, what am I going to get? Right? What's method? Well, yeah, some of you are looking up because that's going to be found in the foo class because I'm inheriting from foo, right? Bar doesn't have a method 1 defined, so it's going to use its parent's method 1, right? So it's going to print out foo1 in that case. Make sense? And if I do system.out. Print line B, that's going to print out what? Well, remember, when you throw an object into a print line statement, what happens? It automatically just adds the toString method onto it, right? That's what happens automatically. So when you print something out, Java doesn't really know how to print it, so it uses the print line command. And if I don't, and it says bar, so I look in bar, it says, okay, I don't have a toString. Okay, let me look at my parent. Does my parent have a toString? Yes, it does. It says to return foo. So we'd print out foo in that case. Make sense so far? Right? If it's not there, we look at our parent. Okay? Now let's go ahead. We also have a class baz. So we have the bar. We have the baz extends foo. And baz doesn't override methods 2. It doesn't override method 2. It overrides method 1 and toString, right? It overrides those two things. Okay? And it overrides them in a non-tricky way, right? We may make it a bit tricky. Dr. Fiore tends to, rather than use foo, bar, and baz, he tends to use IKEA product names instead because they make great nonsense variable names. So baz extends foo. It overrides method 1 and it says baz1. So we're not going to like try to do anything too tricky here, right? We're not going to put global here instead of baz. Okay. So if it overrides method 1, it prints baz1, and toString will be baz. And then we have mumble extends baz, which overrides method 2. Okay, so now we have an array of foo called pity. So it has, and it consists of a baz, a bar, a mumble, and a foo. Okay? Now it iterates over all the items in pity, right? Iterates over all the indices in pity. It prints out prints out the item, then it calls the item on method 1, method 2. So of course the question is, what is the output? Okay? It's a lot to go. It's only a lot because it's on two slides, but let's go through this. It's not nearly as hard as it seems. Okay? We can diagram what we can do is we can diagram this class, right? We have if you really need to work it out, this helps some people diagramming the class, right? We've got foo at the top, and it's got method 1, method 2, and toString, and we note that it's got foo1, foo2, and foo for each of those outputs. Bar has its own method 2, but it gets method 1 and toString from its parents. So if bar gets called, we're going to get foo1, bar 2, and foo. Baz inherits the things that bar doesn't, right? And it overrides method 1 and toString. So we get baz1, foo2, baz, right? And then mumble inherits from baz, and it overrides method 2. So we get mumble 2. So by diagramming this out, you kind of have all the answers there right at your fingertips, right? By diagramming it out like this and just noting, okay, we have these 3 methods. It's not like going to be more than 2 or 3 because otherwise that's going to be hard for us to write, okay? Another way to do it is to create a table, okay? So we put down like foo over here, and then we know that bar's method 2 is bar 2. We know baz's method 1 is baz1, and its toString is baz, and mumble's over here is mumble 2. So we fill out with like everything that's defined, and then we fill in the gaps with inheritance, right? So bar inherits from, you ask what it fills out from its, so you make a table like this. You first fill it out with the things that you're inheriting, right? With the things you're overriding, and then you fill it out with the things you're inheriting. That makes sense to everybody, right? So basically just diagramming the class before you get to the questions or as you're dealing with the questions really will help you. Okay? So we can consult back to these. So baz, let's go ahead and we'll consult back to this table. So the first thing is a baz. Okay? Now notice that it's an array of foos, right? And we can store a baz in there, a bar in there, a mumble in there, and a foo in there, right? Because baz is a foo because it extends foo. Bar is a foo because it extends foo. Mumble is a baz, and baz is a foo, so mumble is a foo, right? Okay, and a foo, of course, is a foo, so you can put it in an array of foos. Okay, so we go through the array pity. So first thing we do is we're going to target baz. So print out baz. So baz has overridden method 1 and toString. So we know that if we print out baz, it's going to print out baz. Then we call method 1, it's going to do baz1 because, right? That's what we call. So if we call the toString method, it's going to print out baz. We call method 1, it's going to print out baz1. And then when we call method 2 over here in the code, right, what's it going to do? Well, it's going to go, well, I don't have a method 2. Where do I get it? I get it from my parent, so I print out foo2. So it goes baz1, foo2. Make sense? Aside from the nonsense words? Okay. So bar, on the other hand, so it's the toString method, method 1, method 2. Bar, on the other hand, is going to go, I don't have a method 1. Sorry, I don't have a toString method, so I'm going to use my parent. So I'm going to go foo. Method 1, I don't have a method 1, so I'm going to use my parent, which is foo1. And then I have my own method 2, so I'm going to print out bar 2. Now, mumble goes, and mumble goes, okay, I don't have my own method 1. Sorry, I don't have my own toString method, but my parent does, so I'm going to print out baz. I don't have my own method 1, so I'm going to use my parents, which is boz1. And I don't have my own, and I do have my own method 2, so I'm going to print out mumble2. And then foo is fairly straightforward. You just print out foo, foo1, foo2. Right? So you get a lot of questions like this. Another times, so the trickier variation of this puzzle, of this problem, by the way, is where we don't put things in order. Right here we have lamb extends ham, and then we have public class ham below it. Spam extends yam, yam extends lamb. So everything in this case is completely jumbled up and made deliberately confusing. And also, in the parent class, every method call, we have A calls the method B. So if you call A, you're going to get ham A and ham B. And if you call B, you're just going to get ham B. Right? So that makes things a bit trickier. So now we got to again, we have to diagram it. So we've got lamb at the top. Sorry, we've got ham, lamb, and then yam extends lamb, and spam extends yam. So so basically it's, rather than having branches, it's just a straight line here, right? Ham is at the top, lamb extends that, yam extends that, spam extends that. So the question is, how does this work? Let's go ahead and grab all of these files, all this text, so we can put it into, just a nice file, into a file to get, one place to read it, rather than just jumping across slides. These questions are kind of designed to make sure, do you understand how inheritance works? And also to deliberately confuse you. I will not, I'm not going to deny that. So here let's see what we've got. We've got an array of 4 items: lamb, ham, spam, yam. We go through them, we print it out, we call A, we call B. So we do the same thing. We do the two-string method, then we print out A, then we print out B. So let's start with how lamb would work. So let's go up to lamb. So the first thing, lamb only overrides B. Okay? And this is where it's going to get a bit tricky, I feel, for a lot of students. Because remember, when we call a method, we are always going to call the most well-defined function. And just because we reference our parents, and here's the other key, just because we're using our parents' method doesn't mean we're actually inside of our parents' class, okay? As you'll see right now. So the first thing I do is call the two-string method. Lamb extends ham. So I call the so I don't have a two-string, so I look at my parents. My parent has a two-string, so I print out ham, right? Makes sense? Then we call lamb A. Lamb goes, okay, I don't have an A. So I'm going to reference what my parents has. Public stat void A. Print out ham A, then call B. Now the mistake is going over here, because that is instinctively what you want to do. You see a B here. But remember, I'm in lamb, so I'm calling lamb's B method. So I print out ham A, lamb B, and then I call lamb's B method, and I print out lamb B. That sounds a bit crazy, right? But remember, when we're inside lamb, we have a B defined, we don't have an A defined. So essentially, remember what happens when you inherit is essentially you get a copy of what your parents is. So really what's kind of going on when I extend here is that I kind of just copy this over into my own class, right? And now that makes sense that if I call A and then B, I'm going to call ham A, lamb B. And I hope to God that I'm right, because otherwise this is going to be really confusing. So lamb's output will be ham A, lamb B. Right? And this is where polymorphism basically happens, right? I'm overrided the behavior in lamb. So let's look at our table. So ham A, what happens with ham A is that basically we do ham A and then we call B. B is ham B, and toString is ham. Lamb just overrides lamb. Yam overrides lamb's A and calls our parent's A method and overrides the toString method. And our parent's method for A is non-existent, so we go to their parent's method, which says print out ham A and call your B method. And then its toString is overridden. And then spam doesn't do anything but override that. So we look at our table. And for lamb, we just copy this over, ham A and B. And the toString we copy over. So, all right. So I would suggest taking about 5 minutes to kind of, or sorry, a couple minutes to figure out this on your own, right? So we've got, let's see, we've got, let's see, how do I get rid of this sidebar? I cannot, apparently. Oh, right, but I can zoom in, which helps only so much. So we've got this, right? So try figuring it out yourself, on pencil and paper or on your computer, what the output for each class would be when you call the method. So I'll give you about 3 minutes to work on that problem. Okay? So try and figure that out. Grab some paper, work on it. Right? Because remember, each method, what we're doing is we're calling their toString method, its method A, and its method B. So take a couple minutes and figure that out. And let me get rid of my face blocking, or the camera blocking that little patch over there. Right? You can either do the diagram or you can do the table to try to figure out these outputs. All right, how are people doing on this? Couple more minutes? And don't worry if you don't get the prints, versus print line. That's fine. Nothing to think about that too much. Here, it's more, are you understanding what each method is going to be doing? Okay, so let's take a look at the answers for this. So hopefully your table looks something like this, if you made a table. So the output is for lamb, right? Lamb would have a, it doesn't, so lamb.toString, it doesn't have anything special. It just calls its parents method, which is ham. Then when we called lamb's a method, it called its parent, which says lamb a, and then its parent's method said to call b, and lamb's b does exist, so we use it. So we print out lamb b, right? Because remember, it's overridden. We just copy what we don't have from our parents, essentially. And then calling b produces lamb b. Ham, of course, is pretty straightforward. You print out ham, ham a, ham b, ham b. Yam, right? Yam, let's see. Yam is a child of, let's see. So let's just double check. Yam is a child of what? Yam is a child of lamb. Okay. And that one's a bit tricky because it says, call my parents' method. So yam says, for its toString, just print out yam. Then for its a method, it says to, okay, I'm going to print out yam A, and then I'm going to call my parent's A method. Well, my parent is lamb. He doesn't have an A method, so we're going to call ham. So we're going to print out ham A, and then we're going to call our B method. Does yam have a B method? No, it does not. Does my parent lamb have a B method? Yes, it does. So we're going to call lamb B. So you always use the most well-defined, basically the lowermost defined version of the method. And if you need to go back up, you can only use super to do so. So it is yam A, ham B, yam A, ham A. Wait, was I working on spam or I was working on yam, not spam. Ugh. Okay, so for yam, it would be yam A. Sorry, it would be the fourth one I was working on. Yam A, ham A, lamb B. And then lamb B. And now with yam, we do have a method defined for B. So instead, we print out spam B here and spam B here. Okay. So there's some more exercises of these on your sheet. Now, remember, with the cool thing about polymorphism is that we can take we can take a class and basically put it in a more general class, right? And anything that's a common behavior we can use, but anything that's not specific, but we can't use anything like that specific to lawyer, right? We can, because lawyer's an employee, we can use get hours, but we can't do sue because we could have done something between these lines and changed up what gets stored in ED. If you do want to do that, you have to cast it. Okay. So let's go ahead and look at some good practice exams. So here is a review sheet I found. I have my own, but let's go ahead and look at what this course suggested for the review sheets. So writing a class is the main method. Declaring, initializing, and assigning variables. Assigning, doing assignment. How assignment works: take the memory location of the value on the right and store it in the left. Numerics, characters, and string literals. In other words, what are and that's just a fancy way of saying actually having a number in your code, actually having a single quote character in your code, or a double quoted string in your code. And our basic data types: int, double Boolean, character, string. Knowing your string functions, definitely want to know length, character at, index of, how to concatenate, know how to do uppercase and lowercase, and know why you want to do dot equals on strings and why double equals doesn't work, right? Because double equals in here is memory location. Let me see if I can't zoom in here because it is a bit small. Okay. So apparently I can. So let's go ahead and... Cool. That's so much better, isn't it? Okay. Expressions. Know basically how to do all these things. Star, slash, plus, minus. Modulo. Plus, plus, minus, minus. And we don't really test this too much, but there is a difference between doing plus, plus and before a variable and minus, minus. And plus, plus after a variable. For instance, if I were to do, practically, in most cases, there is no difference, right? But if you're not doing something like this, x plus plus, and that is your only statement, don't use plus plus, right? It is perfectly valid to do what? So x is equal to, so let's go with int x is equal to 5. Actually, I'll do it on the computer because, again, so you can see it. Notepad. Int x is equal to 5, right? No problems there. X plus plus. That's perfectly valid. That will increment x to 6. However, Okay, now that's a bit interesting. So the question is, what is value of y? Is it 5? Sorry, so is it 5 plus 8 or 6 plus 8? Does the plus plus execute before or after? Well, it depends on where the plus plus is. So when you see an x plus plus, this means that essentially that the x gets incremented after the code, after this code runs. So it'd be 3 plus 5. We'd store 8 in y, and then after all that was done, we'd increment x to 6. However, if I did x plus plus, if I did plus plus x instead of x plus plus, this increments x before we do the operation. So it turns it into, so this would increment x to 6, and then, add 6 to 3, which would give us 9 for y. This is not clever. This is not smart. This is intentionally confusing. It is a bad feature. Do not do this, right? If you want to increment x before you add it to y, do it here. If you want to increment x after you add it to 3, do it here on a separate line. Make your code readable, right? This is me. This is typically used by some professors to like do stuff like that, and test like how well you understand stuff. I would test this in a C course because when you see C code, people write like this because they're jerks. But in a Java course and in an intro course where I'm trying to enforce good practices, do not do this. Likewise, do not use the ternary operator, if you know what that is. Okay, so that's just what the last bit I needed to go over with plus plus and y1. Know that order of operations occurs. Know about parentheses, and basically know what happens when you mix types together. Basically that. If you take a character, it gets turned into an int. If you take an int, it gets turned into a double. If you take anything and put it together with a string, it gets turned into a string. If else and else statements, right? We didn't go over switch statements. They're just a different type of if statements, and I see no reason to go over them. Really, they're in the appendix of your book if you really care about them, but there's really no, but they're just simply another way to do a conditional. While, do whiles, and for. We don't use do whiles too much, but remember the difference between for loops and while loops. You only need actually one of them, right? Any for loop you can write as a while loop, any while loop you can write as a for loop. But the difference is, right, you want to use a for loop for what we call definite loops. For things that you know exactly how many times you want to execute it. Or do you want to use a while loop for indefinite loops, such as like, I don't know how many lines there are in this file, so while there's the next line to read, I'm going to keep doing this stuff. Difference between print and print line, combining literals and variables, right? In other words, how to like do a proper print statement using concatenation. We didn't go over printf. That's how it's done in C, and it's just another way to do stuff. So declaring and using a scanner object. Next, checking if reading the whole next line, reading until you the next character segment. In other words, until you hit a space or tab or new line. Reading the next int, reading the next double. I typically like to just keep it simple and use only next line, and then cast anything I need into that data type. Has next line. Is there a next line? Is there a next double? Is there a next int? Is there a next anything? Also know that there are wrapper classes, right? There's the integer class for all the stuff you want for integers, right? Integer.parseInt to take in a string and grab grab something out and grab an integer out of it. And the same thing for double. I believe I need to know. I'll double check with Dr. Fiore as to what the allowances is. Last year I did convince him to give you guys a sheet of paper as notes. But typically what he does anyway is he puts like he has the score page just like me, and then on the back of that where I put don't panic, he puts a lot of, of the methods that you should know, right? Like, how to do, the scanner has line, the substring method, those kind of things. If I recall. Know how, with arrays, how to, create them, know how indexing works, how to get stuff out of them, how the length variable works, how to use them as parameters and how to return them, how to do the toString method, how to do 2D arrays and nested loops, how we want to use how to use scanner to read a file. We didn't go how to write a file using printwriter, but that wasn't too needed for us. Understanding how try-catch works a bit, right? They're fairly straightforward. Once you get an error, just jump to the catch block. How to define methods. Pass by reference versus pass by value. Everything in Java is pass by value. You just happen to be passing references around sometimes. Remember, in other words, we copy stuff over, right? We copy stuff over in Java, and what happens is that, and the question is, what do we copy? If it's a primitive, we just copy the value. If it's an object, we copy the memory location of that value so that we don't copy over gigabytes of stuff. And then knows your basic stuff about classes that we've been going over. All right, so let's see. I found a relatively good one over here that I wanted to go over. All right. Let's go ahead and take a look. This is a final exam from one class. So the string class uses what primitive type to represent the contents of its string? Int, Boolean, double, character, or answer not shown. So it's asking what are the primitives that are held inside of a string. Right? I've mentioned this a couple of times. A string is an array of what? Is an array of characters. So it holds a bunch of characters in it. Right? That's what it's looking for. All right. Given this block of code, so given the following block of code, which line contains an error? Foo is equal to 5, bar is equal to 42, double foo is equal to 3.5, double baz is equal to 3.1. Which one of these lines contains an error? 1, 2, 3, or 4? 3. Why? You what? Yeah, you're basically redeclaring it. Is I think the more formal term, but yeah, you're using foo again when you haven't done so. It's enough to know that's an error and that Java will yell at you for doing this because foo already exists. You might think, well, wait, we have bar over here, and oh no, it's not bar, it's baz, right? So just be careful with the tiny text sometimes. Okay. What kind of data would you? And I, by the way, have no idea what these questions are. I don't have no idea what the answers are. I'm figuring them out at the same time as you are, and I'm just hoping that I'm good at this. So what data would you use to represent the current speed that a baby is moving an assistive robot? Well, so what data would you represent the current speed that a baby is moving an assistive robot? So in other words, at what speed is something moving? Forget the scenario of a baby pushing a robot around. It's got speed. So let's go ahead. Would we want string to represent speed? Nah, that's kind of like used to describe words. We could technically use a string to describe like the baby is moving at like really slow speed, or maybe he's like taking a step every couple, but it's descriptive, or we'd have to parse something out of it. Boolean, the baby is moving versus it's not moving, not really describing the speed there. It's describing the state. And a double or an integer, and double's probably the better answer here because, right, you can move at fractions of a speed, right? So given the following block of code, which line contains an error, right? So int foo is equal to 17, double bar is equal to 2.7. Bar is equal to foo times 2. Foo is equal to bar divided by 2. So which of these is an error? Sorry? So 3. Let's go ahead and work through these just to make sure. This is an assignment statement. I see nothing wrong with it. And there's nothing wrong with this. And I somehow doubt we're going to be looking for the, did we accidentally assign something twice problem again. So 1 and 2, they're assignment statements. So obviously it's either going to be 3 or 4. So bar is a double. So we're doing 17 times 2. So we're getting 34 and then we're storing an int in a double. We can do that. So we can store it in, because what's going to happen is that it will take 34 and store it in bar, and it was converted to 32.0, right, 34.0. On the other hand, we've got an integer here, and we've got bar, which is 2.7, divided by 2, so that's going to be 1.35. Store that in 1.35 in an integer. We can't store 1.35 into an integer, right, like that, without explicitly casting it. So line 4 is the error. All right, so this is a different set of questions, mathematical operations. So this one was testing us on how do variables work and types and conversions. This one is mathematical operations. So what's printed out by this block of code? So we've got A, B, and C. Okay, so we've got A, which is 13. B is, we're going to do 13 plus 2 times 3. Remember our order of operations. So that's actually 13 plus 2 times 3, right? So 13 plus 6 is 19. So store 19 in here. C is 19 divided by 4 plus 5, right? So order of operations says 19 divided by 4. So how many times does 4 go into 19? Goes into it, well, 16 is the biggest number divisible by 4 that's less than it, so it goes into it 4 times. So 4 plus 5. So I would say the answer is not shown because I'm going with 9 as my answer. You think it's 8? Did I mess up?
Yeah, because I think it should be 19 for B, 4 divided by 19 divided by 4 should be the remainder.
Not remainder.
Oh, yeah, no,
Not remainder, right? We throw out the little bit for it. We throw, right? 6. So let's just double check though. Somebody can double check this one by throwing it into a compiler pretty quickly, right? Let's go ahead and I'll boot that up and come back to that when it's printed out. What's printed out by this block of code? Double A, 18.5. Double B is A divided by 2. Print out B. So not a trick question there. So we are just going to divide 18.5 divided by 2. Remember what happens. We've got this guy. We've got a double over here. We've got an integer over here. So the double gets converted to 2.0, and we divide. Right? We always convert up to the type that can hold more data. So that would be 9.25. Close. Let's go ahead and just... Whoa! Okay. Apparently it doesn't mind, though. 9. Right? Java does not care about your white space. Remember that. Python does. So what's printed out by this block of code? 11, double B. Also, I hate it when answer not shown is put in there because it always makes me paranoid that I messed up when I get an answer that's not there. So 11. So B is equal to 11 divided by 2. So here we're storing 11, the result of 11 divided by 2 in a double. But remember, we convert on only when we have to. So 11 divided by 2 does not have to be converted. They're both integers. So 11 divided by 2 is 5. So we're going to store 5.0 over here because that's the only point where we have to return that. Then we do B times 2. So 5.0 times 2. So that gets converted to, so that goes up to 10.0, stored in C, print that out. A good question that's asking, how well do we know this stuff? So what's printed by this block of code? A is equal to 17. So A to minus 3. So that will give us 14. Okay, nothing too scary over there. A minus 3 gives us 14 over here. Then C is equal to 14 divided by 4.0, oh boy, plus 3. So what is 14 divided by 4.0, right? We actually have to get a decimal answer there. So that's like 3 and a bit. So how much is that bit? So 12 plus 2 is 14. So we're looking at 3.5. So the answer is 6.5. What is printed by this block of code? 17 mod 4. So 17 mod 4, let's see. So we divide this by 4, we get 16. So it would be, the biggest number under this is 16. So 17 divided by 4 is 4 remainder 1. So we print out 1. What's printed out by this block of code? 7 divided by 2. Now, I'll warn you, Dr. Fiore normally skips this stuff and goes straight into kind of like messing with arrays and iterating through arrays. And his numbers are typically do this, but they're stored in arrays. So 7 divided by 2 is 3. And 3 times 2 is 6. Conditionals and logic. Okay, so here we go. What is printed by this block of code? Ooh, P, Q, and R. Don't we always hate these? All right, when they use variable names like that. So 49, 51, and 53. So if R divided by 5 is equal to 9, so R is 53, R divided by 5 should be 10, so ignore this one. Else if P minus Q greater than R, so P minus Q, that's 49 minus 51. Is that going to be greater than 53? I don't even have to complete the math. It's going to be a negative number, so it's not greater than R. Okay? If Q mod 3 is equal to 0, so question is Q mod 3 evenly divisible by 3? Yes. How do I know that just like that, by the way? Right. It is the weirdest trick in the world, and it does not get taught, really, or at least it was something I learned on my own. It does not necessarily get taught in schools, but it's a cool mental trick to know. If you need to know a number is divisible by 3, add the digits together. If that result is divisible by 3, then your original number was divisible by 3. Oh, and you can do this recursively. So if you add the digits together and you get some number that you aren't sure is divisible by 3, add those digits together by 3. Add those digits together and ask, is that divisible by 3? At that point, you should probably be able to tell. But it's just a really neat trick to be able to tell if something's divisible by 3. So 51 is divisible by 3. So that's what happens when we check mod something equals 0. So we'll print out 3. And it's definitely not answer not shown, because we've got an if, else if, else if, else. It has to be one of these. What is printed by this block of code? If m is greater than n, well, m is greater than n, so we'd go with the first one, right? So it would be m minus 3.3, so that would be 14.0. I think that's a very lazy question. This guy was lazy on his multiple choices. But the students sure appreciate it. So we've got 41, 43, and 47. Okay? So I feel like the questions that he's asking, even though they looked similar to what I want, they're of an easier caliber. But that's not bad, because you want to work up to the harder stuff. And remember what I said about going through the practice questions on Dr. Fiore's website, right? He has a bunch of questions on his website, right? For practice questions for his exam. Since you know he's writing the exam, you should probably be able to solve his practice questions. Okay. Oh, this one's tricky. Okay, so we've got Q, if Q is greater than R and R is less than P, or P is less than Q. So the question is, where do the parentheses go around? Do they go around the AND operator or the OR operator? So I guess I have to look up which has the precedence chart in Java. Precedence Java. The Java precedence table. Parentheses, array subscript, and the dot operation are at the same level. right? So there's 15 levels of precedence, which is kind of weird, but most of them make sense. It's this edge case that you have to ask yourself about. So and has a higher precedence than or. In other words, we solve the and before we do the or. So when you see something like this, higher precedence. A larger number means higher precedence, right? Because the parentheses always at the top, right? A good question though to make sure. But with the assignment, assignment has the lowest precedence because you want to do the assignment at the last, right? So that's why that's there. And you get stuff like the ternary conditional, which I just mentioned you should not use. You get bitwise conditionals. This literally means to do the binary and operation, the binary or exclusive or operation, or the binary regular or operation, right? Those are what those means. And we didn't go into binary too much, but that's what a single one of those tend to mean. So so let's go back to the exam we were looking at, right? So that means that we do parentheses over the ands. So we do, so is Q greater than, so is 43 greater than 47? No. So this entire thing becomes false, right? So false or P is less than Q. That bit is true, so we immediately go into 1. We don't have to solve the rest of this. What is printed by this block of code? Is 31 greater than 37? No. Skip this. Is 29 greater than 31? No. Is 37 less than, oh, I'm so sure it's going to be 3. Is 37 less than 31? No. Or is 29 less than, yes it is. So yeah. Again, a really poorly designed exam. He kind of like gives away that the last one, the correct one, is the one you want to do the most work for. You write in a lot of exams, you can kind of get into the practice of but leave. I'm just making sure people leave. that was interesting.
You came over and